Great minds, welcome to Light Vision Academy. Once again, it is your friend and tutor David Chisholm. Light Vision Academy is dedicated to bringing you videos related to mathematics. I want to give a shout out to all my subscribers, and if you're a first timer, I would love you to click on the subscribe button for you to be notified with all of our videos. Thank you and welcome. Alright, welcome to class today. Today we'll be looking at expansion coefficients. What happens when we expand two variables having a positive coefficient? Now in this topic we are only interested in the coefficients of the variables. Alright, now let's go to work. That is saying when we have x plus y raised to the power of n, where n here is a real number n greater than or equal to 0. So n here is not a negative number but from 0 to infinity. So what happens here, because we are only interested in extracting the coefficients of the variables. Now let's get to work using this. Say we have x plus y raised to the power 0, then we have x plus y raised to the power 1, x plus y raised to the power 2, and x plus y raised to the power 3, and so on and so forth. Say x plus y raised to the power n. Now we want to extract the coefficient of the variables when we expand this. Now let's go. First, x plus y raised to the power 0. We know that anything raised to the power 0 is 1 according to the law of indices. Now 2, having x plus y raised to the power 1 gives us x plus y. Right, now the next one, having x plus y raised to the power 2, here we expand this becomes x plus y into x plus y. Right, now when we expand this, we have this as x into x plus y, then plus y multiply x plus y. So this gives us x squared plus xy plus xy plus y squared. Then we have x squared plus 2xy plus y squared. Now here we can see that the coefficient of x here is 1 and y here is 1, but for here x squared coefficient is 1, xy is 2, and y squared is 1. So here the coefficient of x is 1 and y is 1. But here the coefficient of x squared is 1, y is 2, xy is 2, then y squared is 1. Now we move further away. I be now x plus y all cubed. Now when we expand here, this becomes x plus y bracket x plus y bracket x plus y. Now we see here that x plus y squared bracket x plus y squared is the same with x plus y all squared. So there is no need of us expanding again. So we just need to adopt this, that x plus y squared is x squared plus 2xy plus y. Now all multiplied by x plus y. Now when we expand this becomes x times x cubed, or we can decide to expand this one. Here we have x into x squared plus 2xy plus y, then plus y into x squared plus 2xy plus y squared. Sorry, this is y squared y squared. So you need to be careful so that you won't make the same mistake. Now s times s squared is s cubed plus s times 2xy is 2s squared y. S times y squared is xy squared plus y times x squared is s squared y plus y times 2xy is 2s squared y plus y cubed. Okay, here we can see that we are having s cubed plus now 2s squared y is a like term to s squared y. So 2s squared y plus s squared y is 3s squared y, then plus sy squared and 2xy squared is what 3sy squared plus y cubed. Now if you focus on the coefficient again, that of s cubed is 1, s squared y is 3, xy squared is 3, y cubed is 1. So which is we have this as 1, 3, 3, 1. So in this class we are focusing on the coefficients of the expansion. Alright, now in summary, so we can write the power and the coefficients. That is to say, when we have x plus y naught, the coefficients is 1. X plus y raised to power 1 are the coefficients. Let's make it here is equals to 1. The coefficient here is 1, 1 because when we expand this, x is 1, y is 1, x plus y all square. The coefficient here is 1, 2, 1. Now x plus y all cubed, we have 1, 3, 3, 1. Now this is all the coefficient. Now you can do this down to x plus y or n. Now the beauty of this is that we can be able to form the coefficients of the higher power even though we don't expand it. This idea is known as the Pascal triangle. Now what does the Pascal triangle say? It says that you start with 1 and it ends with 1, and if you notice the coefficient of all the first term is 1 and the last term is also 1. Okay, now what happens here, it means that if I want to get the coefficient of x plus y raised to power 4, that becomes, I'll start with 1. Now I'll begin to add in between. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, it ends with 1. Now this is what you will get as the coefficient of the term when you expand x plus y raised to power 4. Okay, now we can move further to say x plus y raised to power 5 becomes, you start with 1, don't forget you start with 1 and you end with 1. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, you end with 1. Right, now we have next one x plus y raised to power 6, that becomes 1, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6, you end with 1. Now you can do this and so on and so forth till you have x plus y all raised to the power of n. Now you see that this shape looks like a triangle. Right, so this is what we call the Pascal's triangle. Now what is the benefit of this? The benefit is that we can be able to expand the power of two or more variables using the coefficients. Once we extract the coefficient from the Pascal's triangle, then we can be able to expand. But there is a trick. Now notice that when we expanded x plus y all squared, we are having x squared plus 2xy plus y squared. Right? Then we are having x plus y all cubed. We are having x cubed plus 3x squared y plus 3xy squared plus y cubed. Now notice that the coefficient is still the same. Here is 1, here is 3, here is 3, here is 1. So what it means is that when I am giving something like 2x minus 5y plus 5y to expand, I only need to extract this from this, then use it in the expansion. Okay, now let's give it a try and see what happens here. Expand 2x plus 3y all raised to power 2. Now here, if I want to expand this, I'll write solution 2x plus 3y raised to power 2. Now notice that the power here is 2. So I will extract the power of 2 when we expanded x plus y raised to power 2, which is 1, 2, 1. This was the coefficient we had. Now what do? We use these coefficients to multiply on the variables. But there is a trick in doing that. The trick is that the power of the first variable will be decreasing while the power of the second variable will be increasing as we use each term to multiply. So here we use the first coefficient, which is 1. Now when we multiply, we have 1 times here 2x raised to the power of 2, because the power is 2. It will be increasing because it is the first decreasing, it is the first term, while this is decreasing because it is the second term, times 3y raised to the power 0. Now plus, we've used the first coefficient, we can now use the second coefficient, which is what? 2 times here 2x raised to power, because here is 2, it's decreasing by 1, here it becomes 1, and here it becomes 3y raised to power 1, plus we use the last one, which is 1 times 2x raised to power 0, then times 3y raised to power 2. Now notice, when you look at this carefully, you will see that this is 2, 1 and 0, while here is 0, 1 and 2. So the power of the first term is decreasing while that of the second term is increasing. Okay, this becomes 1 times 2x squared is what? 4x squared times 1, plus, because 3y raised to power 0 is 1, 2 times 2x raised to power 1 is 2x times 3y raised to power 1 is 3y, plus here 1 times 2x raised to power 0 is 1 times 3y squared is what? 9y squared. So this becomes 1 times 4x squared times 1 is 4x squared, plus 2 times 2x, 4x times 3y is 12xy, plus 9y squared. So what it means is that when you expand 2x plus 3y raised to the power 2, this will be your result. So all I need to do is just to extract the coefficient of x plus y raised to the power 2 and use it in the expansion. Okay, now let's go over to the next one. Let's say that you are asked to expand expand 3x minus 2y raised to power 3. Now here we have 3x minus 2y raised to power of 3, and you see the power is of 3. Now we extract the coefficient of x plus y raised to power 3, which is 1, 3, 3, 1. We use each of these coefficients to multiply this. Then we start 1 times 3x raised to the power of 3, because the power starts from 3, times minus 2y raised to the power 0. Now notice that I'm putting my not sign here because there is a negative sign here. Please do not omit the negative sign. Now we use the first coefficient, we use the second one. 3 times 3x raised to the power 2 times minus 2y raised to the power 1. Right, now 0, 1. The next one, 3 times 3x raised to the power 1 times minus 2y raised to the power 2. Then plus the last one, 1 times 3x raised to the power 0 times minus 2y raised to the power 3. Now when we expand this becomes 1 times 3x cubed is 27x cubed. Now this is 1 plus 3 times 3x squared, 9x squared times minus 2y, then plus 10, 3 times 3x times 2y squared is 4y squared, plus 1 times 3x plus 0 is 1, then here is what? 1 times 1 times minus 8y cubed. So this becomes 27x cubed plus 7 times 9x squared, 27x squared, minus 2y becomes minus 54x squared y, plus 7 times 3x, 9x times 4y squared is 36x y squared, then plus 1 times 1 times minus 8 is minus 8y cubed. So here we are having 27x cubed minus 54x squared y plus 36x y squared, then minus 8y cubed. So what it means is that when you expand this is what you would get as the expansion.